Hello everyone, and welcome to this next video in the Houdini Academy Foundation module. In this video, we are going to take a little sidestep and create the Delete by Distance utility node for our toolset. Now, utilities in Houdini are these little assets that are supposed to be robust, lightweight, and fast. And in general, you're going to use them as any other node in Houdini, such as the fuse node or the color node. They're all utilities of some kind. And we can create utilities of ourselves as well if we need a particular feature that Houdini doesn't provide or doesn't provide well enough. So that's what we're going to do in this lecture today. Now, we will need the Delete by Distance node for several different reasons in the upcoming videos in this class. First, we are going to use it to keep objects apart from one another, such as these ventilation objects on the roof. They need to stay away from one another, and also from the elevator shafts and the staircases. Next to this, if we look at the visualizers, which is going to be the next part of the lecture. I know that I said in the last video this was going to be the next part, but I decided I actually should do the Delete by Distance node first and then work on this. So in case we have the visualizers, we are going to use the Delete by Distance node to prevent elevators from spawning where staircases are. Now, this is actually some functionality that I've added to the tool, and I'll discuss this more when we get to the visualizer video. But the last feature that we're going to use the Delete by Distance tool for is to keep pillars inside the building away from the elevator shafts and the walls as well. So all of this requires some kind of measurement, some kind of selection, and then a deletion of some kind. So this is what this utility node is going to do. Let's have a quick look at the example file and have a look at what this tool is actually capable of. Now, over here, we have the Delete by Distance node inside of the example file, and I might update this a little bit as I build this out, so you might get an updated version in the future. But as you follow the lectures, you will see and get everything that I'm going to offer. So if you follow this lecture, then you will have the latest version of the Delete by Distance utility node that you can use for yourself. So the Delete by Distance node has the ability to grab an object in its second input and then make a selection and or delete whatever is inside of that selection in the primary input. So here, right now, I have a box. And if I move this box around or I scale it up, in its default state, it's going to use the points of this box to select our geometry. Now, I can't really see what I'm doing here, so I'm going to template both these objects. Let's template the mountain node, and then I'm going to hold Shift, and then template the box as well. And this will highlight both of them as a template flag, right? So we can see both of them. That's pretty useful. Then let's grab our box object, and you can see how it's currently deleting everything that's near the points of this box. If I move this over here, it will start deleting those as well. If I move it over like this, then even more so, you can see how it's basically selecting everything at the corner points. Now we can change the tool over into a couple of different states. First, we can change the distance threshold for our selection, so we can select further away. That's pretty quick and useful. We can also invert our selection. So instead of deleting everything near the points of our cube, we can also delete everything away from it. And in this case, we can keep whatever is close to our actual object. Next to this, we can also switch around what type of geometry we're using to detect if it's nearby. So right now we are detecting our points. Let's go ahead and switch this over to primitive mode. And with that, instead of using the points of our cube, we are using our primitives. Now, at this moment, this box is pretty much inside of my terrain. So let's scale it up. And if I go far enough in either direction, and I disable this to some extent, maybe lower it, you can see how it's currently selecting everything on the outside of our box where our primitives are, and the inside is kept hollow, right? Because that's too far away from any of the surfaces of this box to be selected. Now we can work around that by flattening the geometry. If I click on that, then the geometry will be flattened, just like the terrain. Then we make our selection, and then we undo the deformation again with the final geometry. So that will allow us to select everything inside the shape of this box, assuming it actually has a solid top to select anything with. We can also select primitives as well, because right now we're simply deleting points. Switch it over to primitive mode. And now instead we are selecting and deleting primitives. And then we can also use this one, which allows us to turn on if it should only select objects that are completely included in our current point selection. So if I select this, switch it to points, you can see that now we have these points selected based on our current distance and selection method. And then any square that's completely included inside of it, if I switch it to primitive mode, will be kept. With this turned off, it will select every primitive that's just simply attached to any of these points. And then finally, we also have the ability to select by edges. So if I switch to that, you can see how it works similarly to how we did before with the points. But even with the points far away, we can still select these parts of our geometry. And then finally, the last option is to, instead of deleting, simply group our selection. So this will allow us to group to a particular group name. And we can of course see these groups in our group display. So let's bring that up. At this moment we are inverting our selection. So here we go. We now select these particular primitives. And we can of course add a blast node behind this to blast them away, or whatever we want to do with it, really. Since it's a group, we can keep it, we can delete it, we can process with it, you know, the sky's the limit. So that's what this utility node is going to do. Now, in order to build it, I'm going to run us through the process on how to build this utility node. And then after that, we'll take this and we're going to work on the visualizer next. Okay, so now that we know what it's going to do, let's go over to our main scene and let's start building this thing. So over here, to the right side of our network, let's go ahead and add a grid, because I need to set up a little scene here to test everything out with. And I'm going to create a box. Now, just for good measure, I'm going to add a bit of noise to this. So let's add a mountain node as well. And let's boost up the height and the scale a bit, so we have some proper undulations here, right? Some proper deformation. All right, this should do. Then let's go ahead and add a subnet down below here. So let's create a new subnet node. Just an empty subnet container. And I'm going to call this the student utility delete by distance. This is going to be our new utility asset. Let's plug this in, and I want the first input to be the geometry that we're going to affect. It's going to be the first input. And then this box here is going to be our effector, right? It's going to be the object that's going to delete stuff or select stuff. It's going to be in the second input. So let's go ahead and create a digital asset out of this. Let's right click, create digital asset. And I'm going to make sure it's named like this, so that's good. Copy that up here. That should underscore every word. So next, let's go ahead and set up our file path. Let's click on the job folder for our project folder. And if this doesn't work for you, then I suggest you set up your project folder first. Let's go to HDA. And then in here, assuming we set our name properly, we can just click on accept. Student utility delete by distance HDA. Right. Okay. So with that, let's click accept here, and that will create our digital asset and immediately open up our new type properties. So let's go ahead and configure this one first. Over in our basic tab, what I want to do is set it up so it has 2 minimum inputs, 2 maximum inputs, okay, and 1 output. That's all fine. I do want to give this node a unique icon, and I know exactly the node I want to grab it from. I want to grab a distance from geometry node, and then I'm going to open up its type properties. Be careful you don't save this node. It's a native digital asset. Don't override it, okay? Don't click accept, don't click apply, but just copy this text, close the window up here, okay? I can't stress that enough. Don't override native digital assets. Don't override them, ever. But with that, we can now go in here, paste in that icon name, and then go to apply. And this will give us a nice icon for our tool. Okay, I like to do that. It helps me differentiate my nodes. It makes them look more pro. Personally, I don't like having everything look like a subnet icon, but that's just me. And then next, let's also make sure this node has a unique color when we create it. And this is a little trick I like to do. Let's go to scripts. And then in here, we can set up a little Python script. Now, I'm just going to show you the script. I'm not going to go deep into Python here. But just type what I've put in here and it will work for you. So let's go down here to the bottom of our script section and we can find the event handler. Click on that and it will give you a drop down. In here we can say on the event this node is created, we want to have a script. This is the on created script, okay? And by default this is set to Python. That's what we want. Then inside this script, first we need to specify the node that we need to set this to. And that's itself. And to do that, we need to type node equals kwargs. I'm not quite sure what that stands for. I think it's kw arguments of some kind. And then we just say between quotation marks node. And this will basically give us the address for our current node. We can even go so far as to actually check that by typing print node. Okay, so now if I click apply, let's go ahead and test that out. Let's create a new student utility delete by distance node. And the moment we plug this in, well, it's going to give us an error because we don't have any inputs, but on its creation, it should have opened the Houdini console. Yeah, there we go. So if this doesn't pop up on your screen, it could be because it's minimized. Usually it pops up on the front of your screen, so it's fine. If it doesn't, and you don't see this, alternatively, you can go to your Windows, go to the Python shell over here, and then if we create another one, because we do need to create a new one to trigger the script, it will also appear up here, because the Python shell will output any Python-based errors or messages that you write. Now, I have noticed that in the more recent versions of Houdini, when Houdini switched to Python 3, I believe, depending on which version of Houdini you're running, right? In this case, I think I'm running Python 2.7, but if you go ahead and actually run the Houdini version that has Python 3, then it won't output to the console. It will only output to the Python shell right here. That's important to know. But before we go too far into that, let's continue with this code. Next, let's write node.setColor. So in this case, we access the node path. Then we go and say setColor. Inside brackets, I'm going to type who.color with a capital C. This will access the color Python function. Okay, so this will allow us to set a color onto our node. And then inside another set of brackets, At least this is how I found it works. We have to provide a color value in RGB. So in this case, I want to provide a color based on my color swatch down here. If you right click on any of these colors, you can go to edit color. And from there, you can just copy the RGB values. So in this case, I have to close this to actually be able to type, but I know the numbers. It's 0.976, 0.78, 0.26. With this, if you go ahead and type this in correctly, and you then click apply. Now, in case you create a new node, it will, well, still print out that text apparently, so we need to remove that, but it has turned it yellow, so that's pretty nice. It allows us to basically customize our nodes a bit. So let's just go ahead and remove this print command. I'm going to type a hashtag, which in Python is just like the // in Vex. It just comments out the line, and then apply that. Just test it out again. Okay, so now it's created a node, it has a color, but we didn't get any more new console prints. Alright, cool. So I'm just going to continue with the node I have. There's no need to replace it. Let's go ahead and dive inside. So by default, it already gave us an output node. That's pretty nice. Let's go ahead and create our delete by distance script, our delete by distance function. So the first thing that I want to do here is to add some null nodes to the first part of my network, just so I have some nodes with names on them that I can grab off. Let's call the first one under input 1 geometry to manipulate. And then the second one is going to be our selection geometry or cutting geometry. So let's name that one selection geometry in this case. Then I just want to make sure that our inputs also have these names, because right now they don't. If we hover over them, they're still called sub-network input. So let's go to our type properties. Go to inputs and outputs. And I'm just going to make sure this is set up properly as well. So here we have our geometry to manipulate. Then we have cutting geometry. And our output could be just output. Okay, so let's apply that. Now our input dots should be named. Okay. And then in here, let's go ahead and write our first section of the code. Okay, so the first thing I want to do is create a basic group transfer mechanism so we can select points or primitives that are nearby our current selection geometry. And we can do this fairly simply using a group transfer node. And then we can set up however it behaves from there to the interface. Let's create a netbox here. And I'm going to name this one the find nearby points netbox. Then in here, let's create a group node. We'll plug that into our selection geometry. And let's call this group node the exclusion group or exclude group. Now in this case, we are creating a utility node, and we can use this node anywhere inside of our networks. I want to avoid having a name in our groups that's going to conflict with anything else in our geometry. I don't want to mess with that. Whatever comes into this node should also exit the node as unaltered as possible, okay? Because that's what the utility node does. It shouldn't affect attributes or groups unless it absolutely has to. So in this case, I'm going to name this group exclude 001. And it's unlikely that someone is actually going to use that particular name, or that particular syntax, so we should be safe. You can use whatever unique name you want to use, just use it throughout the node, and then later on we'll throw this group away. So I'm going to make sure that it selects all the points on our selection geometry. And then from there, let's create a group transfer node. Let's plug that in. So this one is of course going to transfer our group, right? So we need to set this up. Over inside of its parameters, let's turn off edge groups and primitive groups. And let's select the exclude 001 group. Then from there, under group name conflicts, I'm just going to make sure it says override, just in case someone does use this name. They shouldn't use that name, because we will override it. Then, under the distance threshold, that's going to be the value or the distance that we are going to transfer this particular selection from. So this is going to allow us to select the distance, at least based on this method, how far we are going to select from this cube. And it's going to select from all the points on this cube to the geometry, right? So based on world distance. Let's go ahead and add this to the interface of our tool. So over here, let's grab the type properties. And this will open up the type properties of our delete by distance node. Right? Don't open them of the main asset, open them from the utility. Go to parameters, and then in the parameters, let's go ahead and drag over the distance threshold value. I'm going to set this to a default value of 1, and then drag it in. Now by default, this should already be set up properly, except let's just give it a better default name. Let's name this distance threshold, like so, and then apply that. So that will give us our first parameter to control. Okay, so now that we have the ability to transfer based on a distance from our tool, and let's quickly test it out. Okay, that's working. We are able to select our point groups. They are spreading. And if I go to the outside of the tool, and I grab our cube, I can move it around. I just have a bit of trouble seeing it. There we go. Maybe I change the color to something slightly more visible. Okay, so right now it's selecting from points to points. So you can see how as I expand this cube, we are selecting, but you can also see that our selection originates from the points of our geometry. We're going to change this in a bit. We are also going to be able to select from the primitives or the edges of this geometry as well. But for now, let's go ahead and build on the next section. Okay, so next, let's go ahead and add the blast node, so we can actually delete points with our delete by distance solve, right? Let's go inside. And then down here, I'm going to add a new section. And this one is going to be our delete network. And in here, let's add a blast node. Hook that up. And I'm going to call this remove exclude group. Then as for the group I'm going to select, it is going to be the group we just transferred, so our exclude 001. In here, select it. And as for the group I'm actually trying to select, it is going to be guess from group, because later I'm going to hook this up so we can also select primitives using our points. We'll do that in a minute. Now, at this point, I do want to be able to also invert my selection. So if I click on delete non-selected, it will actually invert the selection I'm making and only keep the points that are selected. So let's hook that up next. Grab our type properties, grab delete non-selected from the blast node, and I'm going to call this one invert selection. As for its defaults, let's keep it to off. That's fine. Let's apply that. So now I have the ability to invert my selection. But you notice that I still have my groups, and when this comes out of the node, I don't want to keep those. So let's create a group delete as well. And I'm going to call this one the group delete exclude 001. Hook it in, select the group, and I'm going to keep group type to any again, because this might be a primitive group as well. So this will clean up our groups if we delete them. Okay, so that will deal with the deletion function. Now I do want to have an alternative function where I actually instead write out my current group selection, so this one, to a different group name, any group name. So let's do this one next, okay, before we start adding all the other types of selections and conversions and all that. Down here on the right, let's go ahead and add another network box, and I'm going to call this one rename group. Let's go ahead and grab a dot from here, and from that I first want to create a group rename node. This one is going to be very simple. We are going to grab whatever our exclude group is, and we're going to rename it to something else. Now the group rename node does actually require us to give it a name. Otherwise it will error out. So I'm just going to call this group instead. Then in our interface, let's grab this and let's drag it in over here at the top of the set. Now I'm going to call this one group name. Very straightforward. And under its channels, group is fine. And I'm going to go to the menu tab and just make sure I remove this menu from this, because we drag this over and it will keep it. I don't want it. And also I'm just going to turn off the use menu altogether, and then let's click apply. Okay, so now we have our group right there. It basically changed from our exclude group up here to this new group. And this of course can be anything. This could be my group, and that works just fine. Okay, so let's go ahead and plug this in so we have a switch so we can decide if we want to rename our group or delete it. Create a switch node here. Let's plug it in. And let's call this one delete or rename. Alright, so let's hook that up too. Let's drag it up top above our group name. This is going to be an integer by default. I'm going to change this to output mode. And then I'm going to change it to an ordered menu, right? Under its default channels, by default, it is going to be set to deletion, so the left input. So inside the menu tab, let's set the first one to delete selection. And the second one is going to be group selection. Okay, let's grab a separator too, drag it in between so we keep this organized. And then just because I don't need to use the group name when we are in deletion mode, because we don't need that, Let's go ahead and add a hide when tag here. So within curly brackets, let's type output mode equals 0. So if the output mode is on delete, then we hide the name field. We don't need it. Apply that. Here we go. So now we can either delete our selection or we can group our selection. Nice. Okay, so with that we now have the basic ability to select points based on an input geometry and based on a distance. And then we should be able to also invert our selection. But this isn't set up yet for our groups. It does work for our deletion, but not for our groups. So let's go over here and let's set that up next. For this, we need to take our original group, the one that came from here, and we need to invert it, right? We need to flip it around. So we can do that with a group combine node. Let's go ahead and create one of those. And then over in its settings, I'm just going to say again, group type, guess from group, because this could be a primitive group. And then I'm going to say exclude 001 equals exclude 001. Okay. Now, in case we want to flip it around, we want to flip this one here, equals to equals all but. And this will select the opposite. So let's grab our invert selection toggle, copy this, paste it in here, and now it will simply invert our selection. But because this is a group combine node, and I'm going to call this one invert group, if we don't actually have our exclude 001 group for whatever reason, it will throw an error. And this is a utility node. I don't want it to throw errors for any dumb reason. Okay, so let's go ahead and create a dummy group as well. Create a group node. And by default, I'm going to set this to a point group, but we'll hook it up later so we can also create primitive groups. I'll call this one dummy group. And we're going to make sure that it outputs our exclude 001 group as well. And now at the moment, of course, it's selecting everything. So I'm going to change its setting to union with existing. And this will mean that whatever it's currently trying to select, it will merge with that. And then I'm going to take my current selection and I'm going to set it to nothing. And we can do that by typing !***, or in other words, the inverse of everything. This will just select nothing in our geometry. It will create a dummy group, an empty group, but it's being merged with whatever group came before. In this case, it's at the points. We'll hook this up later. So with that, we always have a group. So our invert groups node, our group combine, will never error out, never crash, and we will always have our exclude group inverted or not. Next, let's go ahead and set it up so we can also select primitive groups. Up here, below our group transfer node, go ahead and create a group promote node. So I'm going to call this one promote exclude. And we can also rename our group transfer node as well, if you want. Okay, so we keep it all neat. And then in here, let's set it to convert our point group, the exclude group. And we want to convert it to points or primitives. Now this is pretty simple to set up. Let's grab our type properties window. And let's drag this to value here in here. And I'm going to drag it below everything. Then let's give it a name. I'm going to rename this to selection type Well, let's call this one type to select. Under its channels value, I'm going to keep it on points. And in the menu tab, I'm just going to remove the edges and vertices selection options, because I don't really want to convert to that selection per se. If you want to do that, you can, but it doesn't really work well with our delete node, so I'm going to remove this option. Then with that, let's apply that. So now if we go down here, we can switch this over to select primitives instead. Now we can also set it up so it always includes or excludes elements that are not wholly contained within our selection. So if I originally had my points here, if we convert it to primitives, and we turn this on, notice how it only selects the primitives inside of our point groups. So I want to be able to have this enabled. Let's go over here, grab this as well, drag it in, and I think we can just keep the name as it is. I don't need to change this, but I do want to set it up so it becomes disabled when we are actually just using our point selection type. So over here, let's grab our selection type, its name, and then I just want to check what we need to set. So over here in the menu, we have our tokens. In this case, I need to grab our primitives. So if it's in primitive mode, we want to use this option, otherwise we don't. So in here, under the include only elements toggle, go to disable when, and inside curly brackets, I'm going to say if the selection type is not equal to prims, which is the token for our primitives. If that's not the case, then we make this toggle disabled. We make it gray, so we can't press it. Let's click apply. Now, depending on if we're in point mode or not, this toggle will be unclickable. And if we are in primitive mode, we can now change our selection style as well. Okay, so now we have a basic selection method based on points. But I do want to be able to also select based on primitives or edges. And for that we need to set up a slightly different method. Let's go ahead and hook that up next. Up here, I want to grab another netbox. Just gonna move this all over a little bit, make it a bit easier. And then let's call this netbox find nearby primitives or edges. Okay, so let's first set up the system that we need so we can select groups based on the proximity to either one of these two elements. So our primitives or our edges. Let's create a array node. And the array node allows us to measure a distance or a proximity between one object and another. Let's grab our geometry to manipulate, plug that into input 1, and then let's grab the selection geometry and plug that into input 2. And by default, the array node will try to cast array. And we looked at this briefly in the attributes video in Houdini 101. But in this case, I want to switch it over. So its method is set to minimum distance up here. And by default, what this is going to try and do is it's going to take our entire object here and it's going to snap it to the closest position on our selection geometry. And that is not what I want it to do. So let's turn off transform points. Okay, so it's no longer trying to snap all these points to my box object. And then down below, I can turn on maximum distance right here. And even further down, I can say create point group. Now, if I look at my groups, my ray hit group, and I raise the maximum distance, as you can see, we are selecting points. And in this case, these points are being selected based on the proximity to this entire primitive object, this entire box. If any of these surfaces are near our current points, they will be selected. So that works for us, right? I'm going to change this from ray hit group to exclude 001. So we have the same thing like the other one. Okay. And then let's go ahead and set up our group promote here as well. So let's copy this one, plug it in. So now we have the ability to select the same way. We can select our primitives. And then let's add a switch node below here. So we can switch between our point selection based on our points or our primitive selection. And let's plug it in down below here. I'll call this one the geometry to detect switch. Now the first entry is going to be our point selection, so based on our points. Okay, so that's the first one. Then the second one is going to be based on our primitives over here. And then I want to have a third optional selection method, which is based on our edges. So before I continue, let me first set up this switch node and then we'll hook up the edges after. Let's grab this, grab the switch node, plug it in right above our type to select. I'm going to turn this into a ordered menu, and I'm going to call this one the type to detect. Now by default it's going to be 0, and as for the menu items, let's set this up. So our first entry, 0, is going to be points. The second one is going to be primitives. And the third one is going to be primitive edges. Or maybe prim edges, if you want to keep it short. Okay. So with that, let's apply that. And now we have this option over here as well, and we should be able to select based on that. As long as I make sure that I'm looking at the right group here. Yeah. Now you'll notice that we don't actually have a way to select primitive edges yet. Let's go ahead and hook that up too. Let's copy this switch node, paste it, and you can jiggle it around to break it off or use a Y to cut it, right? Then up here, let's plug it into our ray node. And the first entry is going to come straight from our selection geometry. Now this one isn't going to matter because when it's set to 0, it's going to be 0 here anyway. So it's always going to grab from this channel first. But the moment it's set to primitives or primitive edges, we do want to use that. So in case it's primitives, we just want to grab the original input as well. So that's fine. But if it's primitive edges, I'm just going to grab a convert line node. And I'm going to turn whatever primitives we provide into primitive lines. And then feed that to our switch. So with that, we now have the ability to select based on where our edges are located instead of our primitives. And if I go to the end of the network, and I can just go ahead and test this out. Let's go ahead and grab this selection box. Make it a bit bigger again. Maybe if I rotate it and I scale it up, right? Let's grab these edges. And then let's reduce the range. Maybe I haven't set this up. Okay, let's grab the distance threshold. Go to the ray node. And I need to make sure I plug in the maximum distance. Alright, so now this is working. Okay, so you can see it's now selecting based on the proximity to our edges. If I make this a bit bigger on one side, you can see that works. Let's switch this over to primitive selection. Now it selects more because it's actually taken into account these primitives here as well. And then if I switch it to points, it only selects whatever is near that point. So that's working. We now have the ability to select based on that. And of course we can switch it into deletion mode, and then it will delete based on that. So that's good. Now there's one more feature that I want to include, and that's the ability to treat this entire object as a flat object. So we only detect in 2D space, right? So if something's above something or below something, it will still select it, no matter what. Let's go inside, and let's set this up too. Now it's fairly easy to do this. All we really have to do is evaluate everything as flat geometry. And to do that, we can use an attribute wrangle to first store our original height of our geometry, then flatten it, make sure we flatten our selection geometry as well, and then do our processing, and then at the end we restore the height of our geometry back to the way it used to be. So let's do that. Let's grab these nodes, move them up, and I'm just going to create an attribute wrangle here. And let's call this one store elevation, or store elev 001. Again, I'm going to use a name that's probably going to be uncommon enough. Plug that in. And in fact, let's add a switch node too, so we can turn this on and off, right? So if it's turned on, it's going to flatten it. If it's turned off, it's not. I'm going to call this switch the flatten switch. Now, as for the code, it's fairly simple. I'm basically just going to create an attribute that's going to store the height of my points. So here, point y. I'm going to call this one float attribute elevation 001. And that's equal to vector attribute p.y. So that's going to store the point height, right? And then after that, I'm going to take my point position in y and set it to 0. Okay, so we just wrote out our point height and then we collapsed our points down to 0. If I look at what this node's doing, we have a flat grid. Cool. Then next, let's make sure that we can toggle this on and off from our interface. So from the type properties, let's grab this flatten switch here, grab the parameter and plug it in. I'm going to drop it in over here. Let's call this one pre-flatten. Right? And by default, I'm going to set my channel value to 0 because I don't want this to be turned on by default. Then let's turn this into a toggle and let's apply that. So now this will allow it to flatten our grid. Let's copy this, plug it into the right. I'm just going to grab all of these lines here, plug them into the bottom of that switch, hook that up to the top. And for this one, I don't actually need to store my height, so I'm just going to get rid of that code. Because all this needs to do in the end is just either be flat or not. Okay, so now, depending on what I'm doing, if I turn on flatten, you can see how it's able to detect our point positions up here as well. and then at the end I need to return it back to its original state. So let's go ahead and copy our switch and our attribute wrangle again. Drop it down here, grab this, plug it in, right below our delete or rename switch. Plug that in there. And I'm going to rename this to restore height. So in here, in order to restore our height, let's grab our float attribute elevation 001. Copy that, delete the top line. And then instead of setting the point height to 0, let's set it to that. Okay. Now we still have this attribute and I don't want to keep it. So let's also create an attribute delete node. Plug that in. Let's delete the elef001 attribute. Okay, so with that, we now have the ability to select based on flat geometry without actually changing the shape as it comes out of our tool. We are also deleting our groups. In case of our group rename node, this one automatically deletes the group already, renames it to what we want it to be. So at this point, we've set up almost everything. There's only one more thing that we need to do, and that is down here in our dummy group. I need to make sure that whatever dummy group we create, it's going to be the same as our output geometry. So let's grab that, copy that, and let's plug it in here, which should be the same order. So it's primitive first, then point. Yes. So let's plug that in. And now depending on our output, it's going to create a dummy group specifically for that. And that's something that we need to do because if we create the wrong type of group, then in case it's missing, this group combine node is still going to have issues. Or at the very least, it's going to create the wrong type of group. And I don't want that either. But okay, so with that, we now have our first utility node complete. This node should be stable. But before we move on, of course, let's go ahead and test it all out. So we make sure it isn't broken in some way, right? In case I miss something. Let's go outside the node. Let's save it. After we've saved it, let's match our definition, lock the node, and then let's test it out. Right now we are using the group selection mode, so we can see what we're doing without deleting. But we can also switch it to delete mode. That works. Then over here, we can change the distance value. That works too. Then let's switch it over to invert the selection. All right. We can flatten it so it selects everything based on the geometry we have. Then under type to detect, let's switch it over to edges. That seems to work as well. Primitives. That works. And we can change our include only elements feature. Okay. Then let's switch it over to point mode. And we need to change our group visualizer for that. So with that, we have the same functionality. That all works. We can change it to point selection mode. Change it to primitive edges mode. And then let's try out the deletion function with that. So delete selected. Okay. Now you might notice that if you delete based on points, you do get some of these points left over. And this has something to do with how our primitives are removed, but some of these points are not. We could integrate some cleaning behavior into this. I don't always want this, but let's quickly add that as well. Open this up, go down here, and then in here, let's create a clean node. Now the clean node is one of Houdini's useful little cleaning utilities. It has a lot of cleaning capabilities. We'll cover this more when we need it, but right now its default behavior is to remove the generative primitives and remove unused points. And also remove some not a number based geometry, like geometry that's really tiny. So if we use this, it will delete all of our points, and it can also in some cases delete very small geometry. I don't always use this because of that, because sometimes it can delete pieces of my geometry that I don't want, and for a utility that can be a problem. Using a clean node is good, but it has its quirks. So in this case, let's add a switch as well, so we can turn this on or off, and then we can always decide to clean stuff up ourselves if we need to. Let's add a switch in here. And I'm just going to hook this up as clean geometry, or post clean. Okay, let's go to the tool. Drag this in. And let's add a separator below, just for that. So post clean geo should do. Keep it off by default and then accept that. Okay, so now if I look at the output and I turn this on, then we can actually remove those extra points that were left over as well. And this only really happens when you're trying to delete by points. If you delete primitives, this shouldn't be happening. But yeah, so now we have a proper node ready. Alright, so with that, I think we are about ready. The delete by distance node here has been tested. We even added our own little post clean option, so you can use that one if you want. And next to that, we are now ready to add it to the other parts of our toolset, so we can start using it all over the place. Speaking of which, if you have your own projects, of course, feel free to use it yourself. It's all yours. And with that, I think we have reached the end of this lecture. So thanks for watching this one, and I hope to see you in the next video where we are going to start working on the visualizers. So I'll see you in the next video, and have a good one.